All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Woo, woo. How's everybody doing? Good? Good weekend? Yeah? Good. Warm-up number 41 is on your screen. Number 1 reads, simplify. Part A, square root of 48. Part B, square root of 1 over 2. Number 2 reads, add, subtract, multiply, and divide, and they give us two binomials. The first one, I plus 5, and the second one, I minus 2. Part 3, or number 3, reads factor by grouping. The trinomial given is 4x squared plus 13x plus 3. And number 4 says graph f of x equals parentheses x plus 4 close parentheses squared minus 2. I'll give you some time for that and I'll go over it just to make sure we got it. Copy that and go. All right, let's see what we got. I'm going to start off, guys, by doing numbers 2 and number 4, and then I'm going to come back to number 1 and 3. Number 2. So, for addition, once you combine like terms, you should have gotten 2i and plus 3. For subtraction, remember, don't forget to put the negative with a parentheses for the second binomial and distribute, so you should have gotten 7. For multiplication, remember, distributive property, distribute. At the end, you should have ended up with I squared plus 3i minus 10. And remember, there's one more step from there. We're getting closer to this, the lesson that's going to cover all the complex and imaginary numbers, but we're getting there. And last but not least, division. When you put this at your dividend and your divisor, you should have gotten 1 with a remainder of 7i minus 2. Hands if you got that for those 4. All right, good. See you guys. Number 4. It says graph f of x equals parentheses x plus 4 close parentheses squared minus 2. Now, if you guys noticed, I'm bringing back transformations. Who notices that there's that function that they gave us has some transformations? Now, what are the transformations that they give us? Well, let me check. By looking at it, there's a transformation, there's a parameter inside and a parameter outside the parentheses. However, it looks kind of funky because it has f of x. So let me get started with the fact that this is a what? A quadratic. So my parent function was what? F of x equals x squared. You guys remember that? Yes, Mr. Q. All right, that means this is a transformation. So I'm just going to change it just so that we can keep it as the way we've been doing it from the beginning of functions. So let me graph f of x equals x squared. So that means if I take negative 2, what is negative 2 squared? Negative 2 squared is 1, 2, 3, 4. Negative 2, 4. What is negative 1 squared? Negative 1 times negative 1 is 1. 0 squared, 0. 1 squared, that's 1. And 2 squared is 4. All right, there it is. That's my parent function. However, we need to graph this transformation. So, what parameters do they give us? Look at it. Now, some of you are like, I don't see them, Mr. Q. Well, remember the general rule, g of x equals a times f of 1 over bx minus h squared plus k. So by looking at it through that lens, what are my parameters? Oh, we have k. Yeah, and that takes us what? Down. What else do we have? Oh, we have h. And since this is a positive, it's going to take us to the left 4 steps. So we take each point, each of these 4 steps to the left, 2 down. So I'm going to go here. I go, this is 1, 2, 3, 4, and then 1. Okay. So I go 1, 2, 3, 4, 2 down, 1, 2. This one, 1, 2, 3, 4, 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 1, 2. Whoop, there it is. And that's my transform function. And this is our what? Our g of x. Is it coming back? Yes, Mr. Q. Yeah, I'm bringing these back because we need some practice on these, okay? I don't want you to forget these because we're about to get into some new concepts that we apply the same general rule, okay? So with that said, let me go to number 1. So, by the way, number 1 and 3 are things that are problems that we did, concepts and skills that we did since we were in 8th grade. But I'm bringing it back because we're going to need them again for Algebra 2. So let me do number 1. It says simplify. Now to simplify this radical, this should have been a perfect square, but it's not. So I'm going to find all pairs of factors for 48. So what factors, 2 factors multiplied give me 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 times nothing, 6 times 8, 9, and the rest repeat. So here, I need to pick the pairs of functions, pairs of factors where one of the numbers is a perfect square. 1 is a perfect square, but it stays the same, so therefore I'm not using that one. 2 times 24, they're not perfect squares, so I'm not using that. 3 is not, but 16 is a perfect square. 4 is a perfect square, and the last 2 are not. However, if I pick 4 and 12, can't 12 be written as also 3 times 4 and another perfect square? Yeah, so I don't use that one. So that means I'm going to use these 2, so I'm going to rewrite this as square root of 3 times square root of 16. So what is square root of 16? 4. And I bring down the square root of 3, and that's how you simplify this to that. Now for tonight's home play, you're going to end up with some that are like this. As much as I want you to do, it's up to right there, and that's fine. You don't have to simplify to decimals or anything like that. B. For part B, we need to rewrite this. Square root of 1/2 becomes square root of 1 over square root of 2. However, according to the definition of fractions, can we have a radical or a square root on the denominator? No, we can only have integers. So to get rid of this square root on the denominator, I need to multiply times square root of 2. Whatever I do to the denominator, I do to the numerator, square root of 2. So let's see what we have. 2 times 2, that's square root of 4 on the denominator. 1 times 2 is 2, that's square root of 2 on the numerator. Now let me simplify. Square root of 2 on the numerator, and then square root of 4 is 2. This is simplified. Does it come back, some of you? Yes, Mr. Q. All right. Number 3 says factor by grouping. We have 4x squared plus 13x plus 3. So let's factor. Can we take the is there GCF in that one? No. All right. So what goes on the bottom? On the bottom we have 13. That's going to be our sum. However, what goes on top for our product? Since there's a leading coefficient, I multiply 4 times 3, which is 12. So what factors of 12 add up to 13? Oh, 12 times 1 is 12. 12 plus 1 is 3. All right, so those are it. So to do the process for factoring by grouping, I rewrite the trinomial. I bring down the first term, 4x squared. I write down my middle term, which is 13x, but instead of writing 13, I'm going to substitute that with these 2 factors that we found, which was 12x plus 1x. I bring down the last term, which is plus 3, and now we can do what? Group 2 at a time. 4x squared plus 12x, that's one group. 1x plus 3 is a second. So let's check for GCF. What is GCF for the first 2 terms? 4x, we're left with x plus 3. What's GCF for the last 2 terms? The only possible one is 1, and we're left with x plus 3. I see you, Alberto. You're like, 1, Mr. Q. All right. So question, what's left? What's the same on the first term and then the second term after this little plus? Well, x plus 3 is the same, so that's my first factor. And what's left over? The 4x and the plus 1, so my second factor is 4x plus 1. And these are my factors. Yeah, we got this? Yes, Mr. Q. All right, good. All right, let's move on. Our agenda for today. Write this down. Warm-up number 41, we're looking at quadratic equations. And you're like, what? Yeah, we're coming back to them because we need to finish off. I just gave you part of it on first semester. Now we're coming back to them. And for tonight, you're going to have 4 problems per home plate, only. Only 4 problems. All right. Your asynchronous session code is from Nearpod is Q7LIZ, Q7LIZ. Once again, don't fall behind with your asynchronous assignments. Make sure you're submitting your notes. And I'm pretty sure everybody's taking copious notes. Very good. Yeah. All right. So last week, when we met last, I didn't give you any home play. I said you have the weekend off. The only thing I said, the only thing that I want you to do over the weekend is get that permission slip signed. Remember that? Yeah, Mr. Q. Now, some people are like, Mr. Q, I don't have a printer. How do I do that? Come on now. Weren't you guys born with a cell phone in your hand? So just bring up the PDF on your screen, take a screenshot, and then sign over it and send it back. My goodness. I know, right? So make sure you submit that on Canvas. It's on the it's the last assignment on the Intro to Functions. If you don't have it, make sure you submit it as soon as possible, please. And in the meantime, your home play is on the screen. Number 1 says solve each quadratic equation by graphing square roots, factoring, and using the quadratic formula. Equation given, y equals 5x squared minus 20. Number 2 and 3 says solve each by completing the square. Number 2 reads x squared minus 8x minus 9 equals y. Number 3, x squared minus 6x minus 27 equals y. And number 4, it reads solve each by completing the square in the quadratic formula. And the equation given for number 4 is x squared plus 10x minus equals to negative 16. Copy that. All right, so you'll finish copying that on your own from the asynchronous code that you got. Let's get started. Here we go. Our objective for today, can solve and graph quadratic equations by completing the square and quadratic formula. Once again, I can solve and graph quadratic equations by completing the square and quadratic formula. Now, what is the main concept for today again? It's in green, yes, quadratic equations. We're coming back to them again. And we're gonna do what? Solve and graph. So I'm gonna show you the graph portion again, but we already did this on first semester, so we don't need to do it again. I just need to show you what it looks. But we're gonna be solving, but today we're gonna be solving 2 different ways, which is by completing the square and quadratic formula. All right? So everybody go like this really quick, look up, go like this. Bear with me because today's gonna go pretty fast, so stay focused. All right, so let's start with a Frere model. What are quadratic equations? Let's see if you remember from first semester. Quadratic equations, quadratic equations. Quadratic equations are equations or 2 variable equations where the highest degree is 2. 2 variable equations where the highest degree is 2. Examples. For examples, we got x squared plus 3x plus 2 equals y, x squared minus 9 equals y, and y equals 3x squared minus 11x plus 6. Non-examples, x squared plus 3x plus 2, and negative 3 plus x equals 10. Copy that. I'll give you some time, and then I'll come back to that to finish that portion. Copy and go. All right, so According to what we got here, it says, quadratic equations are two variable equations where the highest degree is 2. So let's look at the first one. The example x squared plus 3x plus 2 equals y. It's an equation because there's an equal sign. Two different variables because we got x and y. And the highest degree is 2. That means that it needs to be in standard form to see if all the rest of the terms have lower than 2 degrees or 2 degrees and lower. So look at this first term. This is 2 degrees. This is 1 degree, 0 degree, 1 degree. The highest degree is what? 2. Look at the second one, x squared minus 9 equals y. Highest degree is 2. This one's 0, this is 1. Yeah, highest degree is 2. And the last one, y equals 3x squared minus 11x plus 6. 3x squared has a degree of 2. 11x got the degree of 1. 6 is 0. And y is 1, so the highest degree is 2, yeah. And I can give you more combinations by moving terms around into different parts of the equation, but that's basically the examples, non-examples. X squared plus 3x plus 2, and negative 3 plus x equals 10. Think about it. Why are these not quadratic equations? Look at them. Why are these not quadratic equations? Look at the first two, x squared and then x squared plus 3x plus 2. Why are those not quadratic equations? Jesus, what do you think?
What was the question again?
Why are these not quadratic equations?
Because, I mean, negative 3 plus x equals 10. That's not a quadratic because it doesn't have the squared.
It doesn't have a squared, okay. And it doesn't have a y, okay. How about these first two, Jazio? Why are these not quadratic equations?
They're not equations.
They're not equations, all right. So with that said, what are the most important things to say about quadratic equations? Let's hashtag that. Hashtag, hashtag, hashtag. What makes a quadratic equation a quadratic equation? Alberto, hashtag what?
Hashtag 2 equations, 2 variables.
Two variables, okay, 2 variables. Thank you. Addie, hashtag what?
Hashtag equations.
Equations, thank you. And we got one more attribute. Hashtag what, Octavio?
Hashtag equal sign.
It's the same as equation, so we're missing one major attribute.
Oh, highest degree is 2.
Yes, highest degree 2. All right, so we got this. All right, so we're done with the Fourier model. So let me do a recap of what we did last semester. Look up to the screen, write your utensils down. You don't need to copy this. This is the quick recap. Look up. And it reads, example Q, solve each quadratic equation by graphing, square roots, and factoring. And this should sound familiar because we did that on first semester. So let me solve this by graphing first so you guys can see it. So I'm going to solve by graphing. I'm going to take the equation x squared minus 4 equals y. To graph it, it needs to be in y form or solve for y. It's already solved for y. Next, I'm going to make an input-output table. X, y. -2, -1, 0, 1, and 2. So if I was to substitute the first x value to my equation, -2 here goes into x. So what is that? -2 squared. What is -2 squared? That is 4 minus 4 equals y. So what is 4 minus 4? 0. Next, -1. If I substitute -1 here again, what is -1 squared? 1 minus 4 equals y. So what is 1 minus 4? -3. Next value, 0. If I substitute 0 here, it would be 0 minus 4 equals y. So 0 minus 4 is -4. And the next one, 1 squared is 1 minus 4 equals y. So that's -3. And then 2 squared, that's 4 minus 4 equals y, which is 0. If I graph that, let me graph it over here. Negative 2, 0. So we got 1, 2, negative 2 zeros right there. Negative 1, negative 3, negative 1, and then 1, 2, 3. It's right there. 0, negative 4, 0, negative 4, which is right there. 1, negative 3, which is there. And 2, 0, which is here. This is negative 2. This is 2. And here's my parabola. All right, so we're solving by graphing. So how do we know what are the solutions? So the solutions is if we look at the x-axis, where our graph crosses the x-axis, those are my solutions. So what are my solutions? Let me point to them. Here and here, those are my solutions. And what are the solutions? X is 2 and x is negative 2. Negative 2 and 2, it's also here. Negative 2 and negative 2. All right, so that's by graphing. Okay, let me do the next one by square roots. If I take the equation once more of x squared minus 4 equals y, to solve using square roots, I need to change y to 0. That is x squared minus 4 equals 0. And then I solve for x. So what do? I need to leave x by itself, so that means I need to add 4 to each side. X squared equals 4. And last but not least, to get rid of this squared, I need to take the square root. That's why this method is known as what? Square root. So we're left with x equals plus minus 2. These are my solutions. Did I get the same thing as graphing? Yeah, 2 and negative 2. 2 and negative 2. Okay. Next, the last method is by factoring. So I take the same equation, x squared minus 4 equals y. But now I'm going to use what? Factoring. Okay. So what do I do first again when solving any equation other than graphing? It needs to be in standard form equal to 0. So 0 equals x squared minus 4. Next, I need to factor. I can do the factoring. However, this is a binomial. I don't know if you guys notice, yes, and it's a subtraction, so that means this could be a difference of squares. I'm trying to refresh your memory. Let's see. Let's see if it's true. Can I take the square root of x squared? Yes, that's x times x. I open two parentheses down here, 1x for each parentheses. Next, can I take the square root of 4? Yes, that's 2 and 2, but one of them is positive, the other one is negative, and all that equal to 0. From there, I said each one of those factors equal to 0, x plus 2 equal to 0, x minus 2 equal to 0, and I solve. So minus 2, x equals negative 2, plus 2, x equals 2. These are my what? Solutions. Did I get the same thing as the other methods? Yes. Did it bring back memory? Yeah? Yes, Mr. Q, yeah, we finished this in semester 1. Well, today we're adding 2 more methods, okay? So on your notes, copy this next one. Example 1, and it reads, solve by completing the square. X squared minus 6x minus 16 equals y. And on the right side, I gave you some steps. Copy those, and it reads, step 1, set the quadratic equation in standard form. Step 2, divide the entire equation by the leading coefficient. Step 3, eliminate the constant. Step 4, add b over 2 in parentheses, and then squared to each side of the equation. Step 5, factor. Step 6, take the square root, solve, and then write 2 equations. Copy those steps, so copy that problem. I'll give you some time, and then I'll go over it right after you. Copy and go. All right, let's see what we got. So, the problem at hand that they give us, it says, solve by completing the square. Once again, x squared minus 6x minus 16 equals y. And then I gave you the steps, so I'm going to leave them on the side. So I'm going to go over this one step by step. So writing utensils down, look up to the screen, and I'll have you copy right after. Halfway there, I'll have you copy the steps. All right, here we go. So first things first. Step 1, set the quadratic equation in standard form. How does that look, Mr. Q? Let me show you. The standard form equation is ax squared plus bx plus c equal to y, but since we're solving the quadratic equation, I'm going to set it equal to 0. So let's look at our equation. Does this equation look like that? Yes, except for the y. What does the y need to be? It needs to be equal to 0. So this is x squared minus 6x minus 16. So I'm done with step 1. Once again, writing utensils down, look up to the screen. Focus, please. Step 2. It says, divide the entire equation by the leading coefficient. Once we have the equation in standard form, we go to the first term. The first term is what? X squared. What is the leading coefficient? Well, the number multiplying that term. What is the invisible number right now? It's a 1. So I'm going to divide everything, all the entire equation by 1. So x squared divided by 1 is x squared. Negative 6 divided by 1 is negative 6. Negative 16 divided by 1 is negative 16. 0 divided by 1 is 0. Step 2 is done. Step 3, eliminate the constant. Constant. So, first of all, which is our constant? Our constant is any number that does not have a variable or is not being multiplied by a variable. So my constant here is what? Negative 16. The other number without the variable is 0, but 0 is 0. We can't do anything there. So I need to eliminate negative 16. How can I eliminate negative 16? By using inverse operation. So I do what? Plus 16 plus 16. I end up with x squared minus 6x. I leave an empty space here equal to 16. Step 3 is done. Once again, you're still not copying. I'll give you time. Let me just finish up to the next step. Look up to the screen. Let me go to this next step. If you look at the left side of the equation, I have x squared minus 6x. Now, for the past 2 weeks on the warm-up, I asked you to complete the square of something that looked like this. Is that correct? So how would I complete the square of this binomial here? What do you think, Victor? What would I do to complete this square?
Can you say that again, please?
What would I do to complete the square? Hayden, what would I do to complete this square right here?
Add 6 over 2 squared.
Negative 6 over 2 squared. That is correct. Yeah, to complete that side. But now since we have an equation, I need to do plus negative 6 over 2 squared to both sides. So if I simplify this, this is x squared minus 6x plus 9 equals to 16 plus 9. If I simplify the right side, that's 25. And I bring everything else down, x squared minus 6x plus 9. Copy that, please. I'll give you some time. Go. All right, so you should have copied that. So up to right now, we did step 1, which was standard form, and it needed to be equal to 0. And I told you the standard form is ax squared plus bx plus c equal to 0. There it is. Step 2, we divided by the leading coefficient. Leading coefficient, there's nothing there, so it was 1. Step 3, we eliminated the constant. The constant is negative 16, so we added 16 to each side. And then I said, what can we do to the left side to complete the square? And Hayden said, well, we add negative 6 over 2 squared to each side, since it's an equation, and that takes care of step 4. So we're done with step 4, and then we just simplified and rewrote it down here. Okay, writing utensils down, look up to the screen. Here we go. So, step 5. Step 5 says to factor. Do we know how to factor this trinomial here, x squared minus 6x plus 9? Yes, Mr. Q. I can use the Power Rangers. Yes. However, look up. I'm going to use a shortcut because now I know this is a perfect square. So look up, please. To use a shortcut for this trinomial, I take the square root of the first term, which is x squared. That gives me what? X. Take the square root of the third term, which is 9. Square root of 9 is 3. I use the sign of the middle term, which is of -6, which is minus, and I write this in a squared format equal to 25. That's the shortcut. Now, could we use Power Rangers? Yes, but I'm gonna leave it at that. And right now, you're still not copying, you're just paying attention. I'll have you copy at the end. Next, step 6 has 3 different things to do. We're gonna take the square root first. Why, Mr. Q? Because we need to cancel this squared right here. Then we're gonna solve for x. And then at the end, we're gonna write 2 equations for our solution. So here it goes. I take the square root of the left side of the equation, square root of the right. X squared cancels the squared. Square root cancels the squared. And we're left with x minus 3 equals 2. What is square root of 25? Plus minus 5. I'm going to solve for x because that's the other thing that we're going to do. Let me move this up a little bit. So what do? I add 3, add 3. I end up with x equals 3 plus minus 5. Now that I have x by itself, I already solved, I need to write 2 equations. Why 2 equations? X sub 1, what is that? 3 plus 5. Let me write that. 3 plus 5, and what is that? 8. I'm gonna write my second one, x sub 2. Why x sub 2? Because we have 3 minus 5. 3 minus 5. What is 3 minus 5? Negative 2. These are my solutions, also known as x-intercepts, roots, zeros. Copy that, please. All right, so it looks like we have the whole process down. Once again, at the end, we need to find 2 solutions, x sub 1 and x sub 2. Why? Remember at the beginning when I showed you the 3 different ways, how many x values did we find? 2. Most of the time, we're going to find 2 values, okay? So this is completing the square. We're going to do another one together. Hopefully, we got this down with the second time that we do it together. Here we go, and then I'll give you different looks of other ways that it can look, all right? Here we go. That was example number 1. Let's go to example 1Q. It reads, solve by completing the square. And they gave us x squared minus 4x minus 12 equals y. And let's do this one together. All right. So step 1, I'm going to do that in blue. X squared minus 4x minus 12 equals y. What is step 1? According to the steps that we wrote, it says set the quadratic equation in standard form. So is it in standard form from highest to lowest degree? Yes, except for the y needs to be what? 0. Yeah, whenever we solve a quadratic equation, it needs to be 0 for y. So we write x squared minus 4x minus 12. Step 1 is done. Step 2 in red, it says divide the entire equation by the leading coefficient. So let's go to the first term. What is the number multiplying x squared? There's an invisible what? 1. So that means I need to divide everything by 1. We write x squared minus 4x minus 12 equal to 0. And some of you are like, Mr. Q, why do we have to do that if we get the same thing? Because I said so. No, it's because we're creating muscle memory, guys, because there's going to be some equations that are going to have a coefficient that's greater than 1, and you need to know that step. Okay? So step 2 is done. Step 3, eliminate the constant. So what is my constant here? In the entire equation, the constant is what? Negative 12. How do we cancel negative 12 from right there? The inverse, which is? Yeah, I see Alberto making the plus sign, so add 12. Add 12. That cancels. That leaves me with x squared minus 4x. I leave an empty space equal to 12. So I'm done with step 3. All right. So now look at the left side of the equation. I have x squared minus 4x. If I was to ask you just for that side to complete the square, what would I do there, Danny? How do I complete the square on the left side?
Square root?
No, that's
Or no? Negative 4 over 2
Negative 4 over 2 squared. We add
squared.
that. We add that. Since we do that to this side, we need to do it to the other side. Negative 4 over 2 squared. Let me simplify this. X squared minus 4x plus 4 equals to 12 plus 4. I can still simplify the right side. That's 16 equals, on the left side, x squared minus 4x plus 4. And we just completed the square, and step 4 is done. Let's go to step 5. We're going to factor. We can use Power Rangers or use a shortcut. If I use a shortcut for the left side, what do, Jaziel?
That part I was confused on.
Okay, help her out. Let's see, Mia, how do I do the shortcut here to factor x squared minus 4x plus 4? Alberto, go.
Okay, I'll try my best. So square root of x squared.
Yeah, so that is x.
Yeah, and then of plus 4, right?
Square root of plus 4, so that is 2.
2, and then you take the sign of the middle one.
Sign of the middle, and then write it in parentheses, squared. Yeah, that is correct. So we're done with the factoring.
Sorry for that.
That's right. So, and the last steps, what do? We take the square root. Why? Because we need to get rid of that squared. We solve for x, and then at the end we write two equations. So let's see. Square root of the left, square root of the right. So the square root cancels the squared. We're left with x minus 2 equals. Square root of 16 is plus minus 4. Let's solve for x. So to leave x by itself, I need to add 2 to each side. So I'm left with x equals 2 plus minus 4. So at this moment, we're going to write our two equations. X sub 1, what is x sub 1? 2 plus 4. 2 plus 4, which is 6. And x sub 2, 2 minus 4, because here's a minus right there, which is negative 2. And these are my solutions, also known as x-intercepts, also known as roots, also known as zeros. And we'll get more into the zeros later when we're in another transformation of functions, graphing of functions. All right. Show me the fingers. I'll come to you with these so far. 4 or 5, 4 or 5. Yeah, we got this, because once again, this is something that you learned in middle school, and I'm just bringing it back. And some of you learned it in Algebra 1, which is, like I said, I'm bringing it back, you know? All right, so the only caveat, or the only thing that is going to be different on the home plate, look up, guys. What if I gave you something like this? That at the end, when you got to this step, look up. When you got to this step, you had x minus 2 squared equals to 15. All right, so at that point, I would do what? Square root, we end up with x minus 2 equals square root of 15. However, can we take the square root of 15? No, it can't simplify. So whenever you end up with something like this, even in your home plate, leave it like that, but finish off the next step. What would be the next step? The next step is to solve for x plus 2, x equals 2 plus minus square root of 15. And it's fine if you leave it like that for your home plate whenever you get to some of those that you can't simplify. But if you can, then you finish off like what we did here, okay? But once again, if you have something, a radical that cannot be simplified, you can leave it like that for right now. All right? All right, let's go to the next one. Example 1 mega cube, copy this one. Negative 3x squared plus 18x minus 15 equals 0. Let's see if we can go a little bit faster on this one, all right? Here we go. Negative 3x squared plus 18x minus 15 equals 0. First step, is it in standard form? Yes, from highest to lowest degree, and it's equal to 0, so we're done with 1. Step 1 is done. Step 2, divide the entire equation by the leading coefficient. What's our leading coefficient on this one, Michael? Leading coefficient.
3.
-3, yeah, so we divide everything by -3. -3x squared divided by -3 is 1x squared. 18x divided by -3, that's -6x. -15 divided by -3 is +5. And 0 divided by -3 is 0. We're done with step 2. Step 3, eliminate the constant. What do we do to eliminate the constant, Matthew? Angie, help him out to eliminate the constant.
-5 and -5.
-5, that is correct. We're left with x squared minus 6x, leave the empty space, equal to -5. All right. To complete the square on the left side right here, what do I do there? Roman, what do I do here to complete the square?
-6/2 squared.
Yes, you add -6/2 squared to both sides. Thank you. -6/2 squared to both sides. Let's simplify. X squared minus 6x plus 9 equals -5 plus 9. Simplify the right side. -5 plus 9 is 4. We're left with x squared minus 6x plus 9. We're done with step 4. Step 5, to factor. Once again, we can use Power Rangers or we can use the shortcut. So if we use a shortcut, I take the square root of the first term, which is x, the square root of the last term, which is 3, sign of the middle, minus, we write that as a squared, equals 2, 4. And last but not least, let's go with the last portion, which is taking the square root. We're going to solve and then write our 2 equations. Square root, this cancels that. X minus 3 equals plus minus 2. Let's solve for x. We add 3 to each side. X equals 3 plus minus 2. And then we write our 2 equations, x of 1, which is 3 plus 2, which is 5. And the x of 2 is 3 minus 2, which is 1. Ooh, let's go. How are we doing with these? Yeah? Yeah. All right. So by now, we should be at 4 5s, yes? Showing your fingers, 4 5s? Or how do you feel with these? Yeah, we got these, okay? So check this out. The only one that's gonna look a little bit different is when they give you something like this. Look up, you don't have to copy this. Look up, look up, look up. We have x squared plus 10x equals -9. What do you guys notice? That the constant is on the other side of the equation. Whenever you have something like this, they already did step 1, 2, and 3 for us. Does that make sense? Now, if I was to ask you, how can I complete the square on the left side? What would you say, Hayden? What can I do to complete the square on the left side?
Plus 10/2 squared.
Yes, plus 10/2 squared. Whatever I do to one side, I do to the other. And the rest is history, and the process is the same, okay? All right, so that's the first method that we wanted to bring back. The second method is the quadratic formula. Write this down, please. Let's go, our favorite. Let's see if you guys remember. I still remember when when we were in class, I'm like, all right, guys, today we're introducing the quadratic formula. What is that, Mr. Q? Well, it's x equals minus b plus minus square root b squared minus 4ac over 2a. Write that down. Once again, quadratic formula is x equals minus b plus minus square root b squared minus 4ac over 2a. Quadratic formula, x equals minus b plus minus square root b squared minus 4ac over 2a. We got this, yeah? X equals minus b plus minus square root b squared minus 4ac over 2a. So remember, I repeated it like 1,000 times. You guys remember? Yeah, some of you? Yes, Mr. Q. You went home and they asked, what you learned today? X equals minus B. Woo-hoo-hoo-hoo. All right, so by now you should know the formula. So let's get started with the last problem. Copy this, example 2. Solve using the quadratic formula. X squared plus 16x equals negative 15. And on the right side, I'm going to give you steps. It's 3 simple steps. Number one, it has to be in standard form. Okay. And once again, write it ax squared plus bx plus c equals to 0. Step 2, identify A, B, and C. ID, A, B, C. And step 3, substitute into QF. What does QF stand for? Quadratic formula, yeah. And solve. 3 simple steps. All right, look at the equation given. X squared plus 16x equals to negative 15. Is it in standard form? No. Josiel's like, what does it say right there, Mr. Q? It says substitute into the QF and solve. My goodness, so clear. So this is not in standard form, which means we need to get the negative 15 to the other side. So I add 15, add 15. I end up with x squared plus 16x plus 15 equal to 0. Is it in standard form? Yep, step 1 is done. Step 2, identify A, B, and C. So I'm going to write my standard form underneath this one, the one here. So like that, I can match it to the A, B, and C. So I have ax squared plus bx plus c equal to 0. So now can we match? Yes. What is A? A is an invisible 1. What is B? B is 16. What is C? C is 15. Now that we're done with step 2, step 3 says substitute into the quadratic formula and solve. That means we need the quadratic formula. What is that? X equals minus B plus minus square root B squared minus 4AC over 2A. X equals minus parentheses plus minus square root parentheses squared minus 4 parentheses over 2 parentheses. All right, let's substitute. Let's start with 1. Because that's A. Where's A in our quadratic formula? Next to 4, next to 2. So 1 goes here, 1 goes there. B, I'm going to do that in red. It's 16. That's at the beginning and inside with a square. So 16 and 16. And what is C in green? C is 15. That's at the end after A. So that is right there. We already substituted. Now we just simplify and solve. So here we go. X equals negative times 16 is negative 16 plus minus square root of 16. Square root of 16 squared. What is 16 squared? 16 times 16 is 256, just to save us time. Negative 4 times 1 times 15, that's negative 60. All that over 2 times 1, which is 2. X equals negative 16 plus minus square root. What is 256 minus 60? That's 196, and all that over 2. X equals negative 16 plus minus. What is square root of 196? Well, that is 14, and all that over 2. Next, X equals, at this point I can simplify this fraction. What is negative 16 divided by 2? That's negative 8 plus minus. What is 14 divided by 2? That is 7. Does this look familiar? Yeah, at this point we have x sub 1, which is negative 8, plus 7, which is negative 1, and x sub 2, which is negative 8 minus 7, which is negative 15. And these are my solutions. X-intercepts, zeros, roots. Woo! Woo, let's go. So what do you guys notice about this one? The hardest part, I think, is identifying A, B, and C, writing your quadratic formula, and simplifying. So I think that shouldn't be a problem, right? We got it? Yeah? Yes, Mr. Q. All right, show me your fingers. I'll come to you with the 2 methods for today. 5, 5, 4s, 5, 4s, okay? Reminder, tutoring right after lunch. Be there or be elsewhere. So have a good one, guys. I'll see you guys later. Bye. Peace.
Later, Mr.
Later.